Today, we'll begin our discussion on flowcharting and algorithms. This will give us a foundation for understanding how to organize and present solutions step by step. An algorithm is simply a step-by-step procedure for solving a problem. It is important because algorithms form the foundation of writing any program. To create one, we need to identify three things: the input, the tasks to perform, and the expected output. Now, the way we give instructions to a friend is very different from how we give instructions to a computer, and that's what we'll explore next. Let's look at a simple example to understand how algorithms work. If I want to know my school rank, here are the three requirements. The input is my name, the task is to search for my name, and the output is my rank. This shows why it's good practice to first write down the algorithm before writing any program, because each step in the algorithm will later be converted into actual code. Now, let us compare giving instructions to a friend versus giving instructions to a computer. To a friend, I might say, Step 1, go to the college board. Step 2, search for my name on the board. Step 3, check the rank against my name. But to a computer, the instructions must be much more detailed, like this. Step 1, go to the college board. Step 2, read the first name. Step 3, if this is my name, see the rank and stop. Step 4, if not, read the next name. Step 5 is repeat until my name is found. So this shows how we break tasks into smaller, clear steps, what we call an algorithm. Here's another example, this time with boiling in a kettle. The input is the kettle and the water. The tasks are to fill up the kettle and boil the water, and the output is the boiled water. Again, notice how we break things down into input, task, and output. That's the structure of an algorithm. Now, let us compare instructions again. To a friend, the steps are simple. Step 1, fill the kettle. Step 2, place it on the stove and turn on the burner. And then step 3, turn off the burner when the water starts boiling. But to a computer, we need to be much more detailed. Like this. Step 1, put the kettle under the tap. Step 2, turn on the tap. Step 3, check if the kettle is 90% full. Step 4, if not, repeat until it is. Step 5, turn off the tap. Step 6, place the kettle on the burner. Step 7, turn on the burner. Step 8, check if the water has reached 100 degrees Celsius. Step 9, if not, keep checking. And finally, step 10, once it has, turn off the burner. This shows how an algorithm requires breaking the task into small, precise steps for the computer to understand. Let's try another example. Buying a red shoe size 5 from Centrio. The input is the name of the shop, the color of the shoe, and the size. The task is simply shopping for the shoe, and the output is the red shoe size 5. Again, the process follows the same structure: input, task, and output. Now let's see the difference in instructions. To a friend, it's simple. Step 1, go to Centrio. Step 2, find a shop that sells shoes and pick out a red shoe with a size 5. Step 3, buy the shoe and go home. But for computer, the steps must be more exact. Like this. Step 1, go to Centrio. Step 2, enter a shoe shop. Step 3, check if they have a red shoe size 5. Step 4, if not, go to another shop and check again. Step 5, once found, buy that shoe and go home. This shows how algorithm makes even simple tasks very detailed for computer to follow. So note, writing algorithms is a very important step. The more you practice, the easier it becomes. So try using real-life examples and write algorithms for them. With enough practice, writing algorithms will eventually become second nature. In programming, an algorithm is a set of well-defined instructions arranged in sequence to solve a problem. A good algorithm has some important qualities. The input and output are clearly defined. Each step is simple, clear, and ambiguous. It should be effective compared to other possible solutions. And finally, it shouldn't look like actual computer code. It should be written in a way that can be applied to different programming languages. So these qualities make an algorithm practical and reliable for solving problems in programming. So here's a simple algorithm for adding two numbers entered by a user. We have here step 1, start, step 2, declare variables num1, num2, and sum. Step 3, read the values of num1 and num2. Step 4, add num1 and num2 and store the result in sum. Step 5, display the value of the sum. Step 6, stop. This shows how an algorithm can be written step by step to solve even the simplest problems. Okay? Now let's look at another example, finding the largest among three numbers. Step 1, start. Step 2, declare three variables, a, b, and c. Step 3, read the values of a, b, and c. Step 4, check the conditions. If a is greater than b, then check if a is also greater than c. If yes, display that a is the largest. Otherwise, display that c is the largest. So, if a is not greater than b, then compare b with c. If b is greater, display that b is the largest. Otherwise, display c is the largest. Okay? Then the final step is step 5, which is we stop. So this algorithm shows how decision-making steps are written to solve comparison problems. So algorithms play a very important role in computing and problem solving. They help us break down complex problems into smaller steps. They improve efficiency by choosing the right approach, like quick sort versus bubble sort. They allow reusability by building modular solutions. They make debugging and testing easier since errors can be traced step by step. They ensure scalability so we can handle larger data and more complex tasks. They also serve as a learning framework for advanced concepts. Algorithms improve team communication because they provide a shared logical representation. They help us analyze time and space trade-offs. And finally, they have countless applications in areas like artificial intelligence, machine learning, data science, security, and etc. That's why algorithms are considered the foundation of programming and computing. Now that we have covered algorithms, let's move on to the next part of our topic, flowcharting. So, what is a flowchart? So, a flowchart is a diagrammatic or graphical representation of an algorithm. It is very helpful in both writing a program and explaining it to others. Programmers often use flowcharts as a planning tool to solve problems because they make use of connected symbols to show the flow of information and processing. The process of creating these diagrams is called flowcharting. Here I'll discuss about symbols we used in flowchart designs. First, in flowcharting, the terminal symbol is represented by an oval shape. It is used to indicate start, stop, or halt in a programming's logic flow. A pause or halt is usually applied under certain error conditions. The terminal symbol is always the first and the last symbol in the flowchart. Next is the input or output symbol is shown as a parallelogram. It represents any function related to input or output. For example, program instructions that take input from a device or display output on a screen are drawn using this parallelogram in a flowchart. The processing or action symbol is shown as a rectangle. It represents arithmetic or processing instructions. Operations such as addition, subtraction, multiplication, or division are written inside this box in a flowchart. Next is the decision symbol is shown as a diamond. It represents a decision point in the flowchart. Operations that require a yes or no answer or a true-false condition are indicated using this diamond shape. We have the connector symbol is represented by a small circle. It is used whenever a flowchart becomes too complex or continues on another page. So connectors help keep the flowchart clear and easy to follow so that you can avoid confusion. Finally, we have the flow lines. These are shown with arrows. They indicate the exact sequence in which instructions are carried out. The arrows also show the direction of control and the connection between different symbols in the flowchart. Next, flowcharting in programming is the practice of using flowcharts to plan and design solutions before writing code. It helps programmers visualize the logic, organize a sequence of steps, and clearly communicate how the program should work. So earlier we saw this algorithm for adding two numbers entered by the user. Now, let's try to convert this same algorithm in the flowchart. So here we have each step of the algorithm, starting declaring variables, reading values, performing the addition, displaying the result, and stopping will be represented using flowchart symbols. So I have opened my Draw.io. This is where we'll create flowchart for that algorithm. So you can check this link below if you want to use this website. So we have this. We'll start with flowchart version of the algorithm we just saw. We begin with start. So what should we use? We use the ellipse, an oval shape. Then declare the variables num1, num2, and sum. So we get the process, which is the rectangle shape. Next, we add a flow line here, connecting the process. Next, we take the inputs for num1 and num2. So, what flowchart symbols do we use is the parallelogram. So, let's say input num1, connect this. Let's create another parallelogram. That would be num2. Connect it. After that, we perform the operation sum equals num1 plus num2. So how should we do that? We'll use the same flowchart symbols because it is a process, because we're adding two numbers. So implicit sum is equal to num1 plus num2. Then let's connect the flowchart symbol. Then we display the result stored in sum, which is the output symbol, that is the parallelogram. So display sum. Finally, the process ends with stop. So let's try it. So in algorithm, we'll step 1 start. Step 2 declare variables num1, num2, and sum. Here I just separated these two, input num1, so that you can understand it in detailed. Which is first we input num1. After we input num1, we will input num2. Next, the process, which is sum is equal to num1 plus num2. After we get the sum, we will display the sum, and the stop, which is that is the end of the flowchart or the algorithm. So this shows an algorithm can be directly converted into a flowchart using the proper symbols. Here is another example, this time to find the largest among three numbers. Here's step 1, start. Step 2, declare three variables, a, b, and c. Step 3, read the values of a, b, and c. Step 4, use conditions to compare them. So let's back it again. If a is greater than b, then compare a with c. If a is greater, display that a is the largest. Otherwise, display c is the largest. If a is not greater than b, then compare b with c. If b is greater, display b is the largest. Otherwise, display c is the largest. Then we'll stop the algorithm. So this is the algorithm. Next, let's see how we can represent it in a flowchart. So let's go back to True IO. Let's clear everything. First, our flowchart starts with the start symbol. Then we declare three variables. Declare a, b, and c variables. Now let's connect them. So note that these will be the numbers that we compare, a, b, and c. Next, the program takes three inputs. First a, input a, input b. Let's connect it. Finally, we have the input c. So at this point, we now have three numbers ready for comparison. The first decision is a greater than b? So what flowchart symbols do we use? It's the diamond. So is a greater than b? Let's connect it. So if a is greater than b, then we'll compare it, the variable a, to letter c, which is another condition. Is a greater than c? We'll connect that here. So if a is greater than c, then we will display the output. That is, display A is the largest number. Connect that. Then we'll add the end terminal. So let's go back here again. What if A is not greater than B? So let's compare B to C. So let's add another decision point here. Is B greater than C? Let's add here. Say no. So how about let's check here again. Is B greater than C? So if this condition is yes, then we'll display B is the largest number. Display B is the largest number. So let's place the condition here. So what if B is not greater than C? Of course, we will display here. C is the largest number. Display C is the largest number. So note, place it another flow line here. Set condition here. You can see also here that if A is greater than C, so what if A is not greater than C? Then we'll add another flow line here. So the end terminal, let's place it at the center. Here we go. So let's try to review it again. First, start. We declare three variables, A, B, and C. We'll input A, we'll input B, we'll input C. If A is greater than B, let's say 10 is greater than 5. So yes, we'll move to another decision. Is A greater than C? If yes, display A is the largest number. Let's go back again. What if A is not greater than B? Then proceed to another decision. That is no, which means it says no, A is not greater than B. So from this decision, let's check, is B greater than C? If B is greater than C, we'll go to this line, display B is the largest number. If this condition is no or not true, that means C is the largest number. Same goes with this condition or decision. If A is greater than C, no, then display C is the largest number. And we will end our program. Now, let us look at another example, checking if A is even or odd. Okay, back again. Step 1, start. Step 2, declare a variable called number. Step 3, read the value of that number. Step 4, use a condition. If the number modulo 2 equals 0, then display number is even. Otherwise, display number is odd. And step 5, we stop. This is the algorithm, and just like the earlier examples, we can also represent it as a flowchart. So back to draw.io, we start. Then declare the variable number. Oops. Declare the variable number. Then we read the number, or let's say input number. Next, there is a decision point, because we're checking so let's check if number modulo 2 equals 0. So if the answer is yes, which is number is modulo 2 equals 0, that means let's check if there is a remainder or not. It's basically a division, but it's checking if there is a remainder. So if there is no remainder, we'll display number is even. Set yes here. If this has a remainder, then that means this number is odd. So we'll end our flowchart with so the process ends. This shows how an algorithm with a condition is represented using a decision symbol in the flowchart. And that's it for today's lesson on algorithms and flowchart. I hope you learned something new and found it easier to understand with the examples we went through. If you enjoyed this video, don't forget to hit that like button and subscribe to the channel for more lessons like this. Thank you so much for watching, and I'll see you in the next one.